So I can hear the wind blowing. So hopefully the recording works this time. But please yell out if you do get a chance and you've noticed that I've frozen or anything like that, because we've got wild weather again today. But welcome to Workshop 6. So I'll quickly start with an acknowledgement of country. So I would like to begin by acknowledging the traditional owners of the land on which I come to you today. I would like to pay my respects to the elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people here today. I would also like to acknowledge the enduring connection the Doodaroa, Yorta, Tangerang, Waywuru and Bangarang people have with what is now considered Indigo Shire. I respect that the land was never ceded. It always was and always will be Aboriginal land. So the agenda quickly. So we'll start with a recap. We'll look at the Burke Museum Geological Specimen Collection briefly, and then we will get to hear from a special guest today. So we have Oscar Lindenmayer, the collection manager for geosciences at the Museum's Victoria Research Institute. So this is one that I'm quite excited for. So I can see you there, Oscar. Thank you so much. And we'll talk to you soon. So quickly, the recap from last week. So we looked at risk, rights, and valuations. So risks being factors that impact the preservation of an item. So that can include risks to the handling or risks to a person who is working with an object. Rights, so that's looking at copyright and intellectual property right obligations, especially when reproducing images of collection items. And valuations, so the monetary worth of an item or a collection estimated by a valuer. So we use an expert for that. So looking at the Burke Museum Geological Collection, we have quite a range of items in our collection, a lot from the local area. So a lot have been, I apologize for my "and" instead of "and", but we have a lot of items from this region that were collected a lot by notable individuals, as well as broadly from the community, as well as specimens from all over the world. So the common finds in the area around Beechworth is alluvial gold. So a big part of the finds started with the gold rush, and as well as gemstones and plenty of granite, which I'm sure you know from me complaining about it for the last 6 weeks. So the original Athenaeum collected geological and mineral specimens to use to educate potential prospectors. So it was very linked to the gold mining and mining more broadly in the area. The significant collections were donated by people like Alfred Selwyn and Edward John Dunn. So they were both prominent geologists of their time, as well as curator Roy Harvey, who you might remember from the Street of Shops focus. He is the same museum curator. He did a lot of donating to the museum as well. So a quick look at two key figures. So they were very significant in the Athenaeum in the early days, as well as significant broadly in the industry of geology. So here is Alfred Selwyn, and he was originally from England, moved over to Australia. So as you can see, I won't read these line by line, but he was the director of the Geological Survey of Victoria, as well as the director of the Geological Survey of Canada, the president of the Royal Society of Canada. So he was known as someone who had very high standards in the industry and fostered a very good team under him, especially relevant to us is the part that's the Geological Survey of Victoria. So then there's also Edward John Dunn. So he is very significant in this area. He also has a mountain, so around Mount Buffalo, which is about just under an hour and a half from here. He has a location named after him. It's Mount Dunn, which for some reason I will always find a little bit funny because it sounds just like mountain to me. So once again, you can have a little bit of a read of his timeline, but he's quite significant because he moved to Beechworth when he was still a child. By the time he was 16, he was known for his avid collecting around the area, and that's when he joined the local land survey office and then was transferred into the Geological Survey of the Mines Department. So that's where he started training under Alfred Selwyn. So he did a lot of work, as well as in Australia, a lot of work in South Africa and England when he went home. And he produced a lot of geological maps and reported on a lot of mining. So that's in Victoria as well as South Africa. So I would highly recommend giving him a bit more of a read than you'll get information-wise from me now. But I will now jump to, so sorry, just to loop back, these are two very significant donors to our collection. So a lot of the items that you'll see on display in the Burke Museum have been donated by one or the other. So I'll now bring you to a very exciting special guest. So we'll be hearing from Oscar Lindenmayer. He's the Geosciences Collection Manager at the Museum Victoria. I will say it is very kind of him to join us today, because he's very freshly back in Australia. So he was presenting at the Mineralogy and Museums conference, which is run by the International Mineralogical Association Commission on Museums. So I'll give Oscar a little bit of a spiel and then hand over to him. So Oscar is the collections manager of the geological collections. So that includes minerals, gems, rocks, ores, meteorites, and tektites at the museums, at Museums Victoria. He has studied geology, the history and philosophy of science, and gemology, and has worked with geological collections for over 10 years. He is an Australian representative for the International Mineralogical Association's Commission on Museums, chairs Museums Victoria's Natural Sciences EMU Working Group, and was a key contributor to the first major geological data exporting initiative at the Australian Museum. Oscar has professional interests in the history of geological collections in Victoria, sharing under-recognised stories those collections relate to, and documenting unusual mineral occurrences, particularly of gemstone materials in our region. So I thought this is maybe the perfect person to speak to when looking at how to catalogue geological collections. So I'll stop sharing now and I'll jump across. Oscar, are you there?
I'm here. Thanks, Molly.
Fantastic. Well, thank you so much for joining us today, and I'll hand over to you.
No problem. I'll just start sharing my screen. Has that gone ahead?
Yep.
Great.
Yeah, right. Perfectly.
So thanks for that introduction. It's always nice to hear nice things about oneself. I guess by way of a little bit more on my background. So as Molly mentioned, I studied geology initially. I did my undergraduate and master's degrees at the University of Melbourne. And I've worked with two different geological collections. One was a large collection with a sort of mining industry focus. And I worked on that for about 4 years. And now I've been at Museums Victoria for about just over 6 years. And so I like to think that gives me as good a background as anyone in talking about cataloguing geological specimens, but I'll also talk more generally about, I guess, scientific collections and why they're important. So I've just covered the first point there of what I'll talk about. I'll also talk about the FAIR principles, which you might have heard of before, but I'll talk about what those are, why they're relevant, particularly to scientific collections. I'll give you an overview of the collections I look after and talk about what information we want to record for geological specimens and why. I'll then give you a worked example of a catalogue record from our collection at Museums Victoria, and then go over an example on Vic collections from the Burke Museum collection that's been done before. And then we'll see if we get time after all of that to talk a little bit about some of the hazards that are present in geological collections. And it's just sort of a bit more, I guess, broadening the discussion, but hopefully we'll get there. So scientific collections, how are they different to social, historical, and art collections? I guess the first point there, the fact that they represent a physical link to or an embodiment of narratives is, I guess that's largely a similarity to these other kinds of collections. One of the differences is that for scientific collections, often these narratives, they don't have to concern humans. So these could be narratives around biological evolution, things like deep time. So talking about, the span of time well beyond human experience, going back billions of years. Things like plate tectonics and continental drift, chemistry and physics, some of these broad, you might call them universal concepts, as well as the human stories. So that could be the stories of their collection, those sort of historical stories. Some of them, for instance, just to take an example from the geological collections, we have examples of greenstone material quarried by Wurundjeri Wurrung people from Willamie Mooring or Mount William, which is quite a significant greenstone quarry that dates back many thousands of years, and material from that quarry in central Victoria has been found as far away as southern Queensland. And so some of these human narratives are really important as well. A way that scientific collections might differ from social and historical collections is that part of their role is to act as the source of truth or a reference point for studying environmental change. And so whether that's, a stream sample of sediment or of insects or something from a particular time and place, that gives you a reference point if you're trying to study what's going on in that time or that place now, and trying to see how these things might have changed. So, for instance, we have specimens in the geological collections that have been studied for, say, beach sands for their microplastic content that were collected 50 years ago, and you can compare that to now and look at how that content has changed. Another point of difference is the relative importance of community and an expert or technical audience to those collections. And so, obviously, both of these are important audiences for any museum collection, but there are examples. For example, the tissue bank collection at Museums Victoria that really doesn't have much of a community output. It's really, these are frozen tissue samples off roadkill animals and things like that are, excuse me, just getting a phone call. And so I guess maybe the geological collection sits somewhere in between that extreme example and something like the Burke Museum collection. And another point is that the value or significance, hopefully that's the end of that, in many cases isn't recognized or can't be recognized at the time of accession. So we're collecting to get a representative data set, and we might only realize the importance sometime later. And so a nice example of this is a specimen of a mineral called muon and it's quite a rare mineral. And this was found, this is the third occurrence throughout the world that we recently found in specimens in the collection at the museum here. And these are specimens that have been sitting unrecognized in our collection for over 150 years. They're scalings off sort of weathering products on one of the Cranbourne meteorites. And what you're seeing here on the left is an optical image of this green blobby stuff. And on the right is a scanning electron microscope image of a part of that same optical field of view. And you can see the tiny little crystals of this very rare mineral. And we've recently documented this occurrence. So something that we talk about a lot with scientific collections is the FAIR principles. And so these are that data, and we can, to some degree, apply this to collections themselves. Should be findable, accessible, interoperable, and reusable. And so what we mean by each of these: findable, really we want to be able to, if some work, for instance, was done on a particular specimen 100 years ago, we want to be able to tell exactly which specimen that was, and an important part of that is assigning and maintaining unique identifiers. Accessible, obviously, that's an important word in museum collections. Any collection or any data is only useful as far as we make it available to people who want to use it. Interoperable, this is a really tricky one. Basically, what we mean there is that we want data that's collected at different times by different people to have some standards that allow them to be used together. I think the person who designed this graphic might have realized that this is a particularly challenging, probably the most challenging of these 4 principles, because the set of 3 gears there they've put in the graphic won't actually turn together. And of course, we want this stuff to be reusable. So I think that's where collection management and conservation play really important roles in maintaining this material for the long term. So a bit about the collections I look after. There are 4 sub-collections. The mineral collection is the largest and most frequently accessed. We have over 57,000 now mineral specimens in the collection, including over 3,000 mineral species. And I'll talk a little bit later on about what I mean by mineral species. You've probably heard of biological species before, but maybe not mineral species. We have 20,000 registered rocks and ores and many more unregistered. So that's largely the legacy of some very large collections that were transferred to Museums Victoria in the late 80s. And we've gradually been working through, but it's more than a lifetime's work. We have 550 meteorites. It's quite a significant collection, even though it's relatively small. And tektites and impactites, these are terrestrial rocks that are the result of meteorites impacting the Earth. And so we have 6,000 of those in our collections. And particularly important there are the Port Campbell tektites. So Port Campbell in Victoria is one of the world's sort of most well-known sites for collecting tektites, and these have an important story to tell in terms of meteorite impacts. So why do we keep all this stuff? Basically, we want to ensure long-term preservation. And so we want to make sure the specimens in our care are physically and chemically well preserved. Often people think, well, they're just rocks, they'll be fine to just sit wherever on a shelf. But often that's not the case. Many minerals are vulnerable to chemical degradation because of things like fluctuations in humidity. And we also need to physically guard them. Many are fragile. We want to maintain findability and facilitate access and prevent dissociation. So the information that goes along with those specimens can be just as important as the physical specimen. We provide access to rare specimens. So that includes rare and unusual examples of minerals, gem materials, meteorites, and providing access and maintaining difficult to recollect specimens. So this might be specimens that have been collected at great expense, like those collected from Antarctica, those from the deep sea. Some mines have been entirely mined out, and so we maintain material from those, and dangerous and restricted areas. So increasingly there are places that were perhaps relatively easy to collect from not very long ago that are now hazardous, or landowners wouldn't like people to go and recollect, that sort of thing. And of course, as with any museum, exhibitions and education are an important part of what we do. But those first 3 points really come down to reproducibility, which is an important concept in science. Really, you might say that it's a core part of the scientific method. Your experiments, your data collected should be reproducible. Okay, so for the next few slides, I'm going to shift tack a little bit and just give you a really brief crash course on how we catalog geological materials, and that necessarily involves talking about how we classify them, things like that. And so what's a mineral? What's a rock? A mineral is a naturally occurring solid material with a defined chemical composition and defined internal structure, usually crystalline. Now that's a bit of a wordy and very specific definition, but I think so. If you're a non-expert cataloging geological materials, it's not important necessarily that you're able to go out and identify everything, describe everything in a perfectly scientific way, but I think it's important that you have a reasonable understanding of the basic concepts so that you can, for instance, understand information that you've looked up, or if you're writing something about the significance, you want to be able to make sure you're using the terminology properly, that sort of thing. Mineraloid, I've just thrown this in there because occasionally you might come across this, but basically it's something that's like a mineral but isn't a mineral. Things like natural glass or obsidian, amber, opal, things like this, which are not crystalline. They don't have a defined chemical composition, but they're found as geological materials. Another example might be coal. And a rock is a solid aggregate of minerals or mineraloids. And so a few examples of each. That calcite specimen from Mexico there, probably everyone here would have agreed before I told you the definitions that that's a mineral, but maybe some people wouldn't have thought that water ice, natural water ice, is a mineral. Something like that obsidian or the precious opal I already mentioned, they're mineraloids. And rocks, so whether it's something like the quartzite, which is essentially composed of one mineral, quartz, or that garnet gneiss, which has at least 3 minerals, garnet, quartz, and feldspar. In either case, you'd still call those a rock. So what do I mean by mineral species? So each mineral species is a unique combination of chemistry and crystal structure. And you can have examples where you've got the same crystal structure. So these 3 minerals, andradite, grossula, and spessartine, are all members of the garnet group. They have the same structure, and that's reflected in having the same crystal habit. They've got these sort of soccer ball shaped dodecahedral 12-sided crystals, but they've got different chemical compositions because even though that structure is the same, different elements will swap into the places in the crystal lattice. Whereas you can have something like these 3 aluminosilicate minerals, kyanite, andalusite, and sillimanite, which all have the same chemical composition. We've got 2 aluminium atoms to 1 silicon and 5 oxygens, but those are arranged in different ways, producing minerals that look different and that have sometimes quite different properties. Mineral species and versus varieties is an important concept. Often you might have heard of something like amethyst or citrine. So these are not mineral species names, these are variety names. So the 2 faceted gems on the right there are the amethyst variety of quartz and the citrine variety of quartz, both from Beechworth. Essentially those are, if you chemically analyze those or did some complex physics to look at the crystal structure, they'd virtually look identical. In fact, if you heated up that amethyst to about 400 degrees, it would turn orange. And so really these are the same species, but we have names because sometimes it is important to refer to, give a general name for ones that are purple versus ones that are orange. Similar things going on with the two corundum specimens on the left. You might, I'm sure you've heard of rubies and sapphires. And these are actually both the same mineral species, corundum. But ruby is the name we give to red corundum, and sapphire is the name we give to every other color of corundum. And in that bottom left image, probably the little grain on the top right, I would call a ruby. Everything else there is a pink sapphire, a blue sapphire, a green sapphire. So I've thrown a lot of information at you about these things. A really good place to go if you've just been given the name of something and you want to find out, is that the name of a rock? Is that the name of a mineral? Is it a variety name? Is mindat.org. It's a really useful website, not just for information about particular minerals, but also about the localities that minerals have been found at. And as I talk more, I'll explain some of the importance of localities as well. Just a quick comment on naming rocks, because I've talked about naming minerals. Naming rocks is a bit more of a dark art than naming minerals. The rock on the left there, I could plausibly and correctly be given these three different names. The first one is a name based on how the rock formed. The second one is the sort of name that tends to get used historically or more sort of to describe regional geology. And the third one is based on the minerals that it contains. And really, we'd have examples in our collection that have been named in any of these three ways. And sometimes very similar rocks have been named differently. The diagram on the right is just to show you some of the lengths that people have gone to try and I guess, standardize some of this stuff. So this is how you name igneous rocks that have cooled underground and so formed coarse crystals. I'm sure you've heard of granite, but probably haven't heard of most of these other names. And these are all based on the relative proportions of quartz up the top, alkali feldspars on the left, plagioclase feldspars on the right, and feldspathoids on the bottom. So these are 4 different mineral constituents, and the relative proportions determine what name you give these things. So 2 other really important pieces of information when we're cataloging geological specimens is locality information and the previous numbers and or collection names. And so locality really is the key piece of information. If we know the locality, then anything else we can probably figure out after the fact. We have the right experts, the right technology that we can identify what a mineral is. We can identify several minerals and work out what a rock is. But if we've lost that locality information, then it's gone. And really that limits the use of that specimen, particularly when it comes to its use for research. And previous numbers or previous collection, sort of what previous collections that rock might have been in, partly they're just interesting additional historical contextual information, but also they can be really important for reassociating a specimen with its lost locality information. And so an example I can show you here, this is a nice metamorphic, sort of high-grade metamorphic rock from Bulio, Victoria. And this was part of the Geological Survey collection that was transferred to Museums Victoria in 1987. And it was registered in 2000. And you can see the top left, that was the label that accompanied it. And so someone has said, okay, well, that's, I can Google Bulio and find out where that is. And so that's the best we can do. And that label on the bottom left was its original label within the Museums Victoria collections. You can see on the rock, there's that circular label with a 3302. So that's not the number we've assigned it. That's a pre-existing number. And it's quite a distinctive label with that sort of corrugated edge. This is what the back looks like. It's got another number on it, 100, and another quite distinctive label. And there's the E15466 that is its number in the Museums Victoria catalogue. And so using that number and this number, I was able to go back to the Geological Survey catalogues. And if you look at 3302 here, this is a catalogue from the very early 20th century. 3302 has the field number 100. And if you can make out the handwriting, it says from a gully 10 chains north of northeast corner of allotment 37, section A, parish of Bullio. And the identification is a nice. So that seems like a pretty good, watertight case that is that specimen. And so we've got, rather than being located to just, a several 100 square kilometre parish, we've got really down to the metre locality for that specimen. And just as an aside, this is a photo I took of a specimen on display in the Natural History Museum in London recently. And that label and that quite messy handwriting is quite distinctive. And that's another E.J. Dunn specimen. So he got around. Okay, so general guidelines for cataloging, and I guess particularly in for cataloging geological material. Consistency is more important than perfection. We're not expecting you to be an expert. I get things wrong. I go back and look at things I cataloged years ago and think, why did I do it like that? So, the important thing is that you do this consistently so that you can systematically go back and make corrections if you need to. Describe the specimen in front of you. So, you can always find lots of contextual information about, say, what granites are like in general. But if you're cataloging something, particularly if it's asking you for a description of that specimen, think about, what's in front of you. The little sort of trick that I like to use is, imagine you've found this item without any labels or numbers, and what would you need to know in order to re-identify it based on that description? And especially for describing labels of old labels or numbers, you want to make your records both human and machine readable where possible. So if I wanted to go back into my collection data and I found a number in red ink written directly on a rock, I want to be able to bring up the list of all of the previously catalogued specimens that had that kind of labeling style, because I might have found out some piece of information that says, actually, that's from a particular collector, and I want to be able to go back and add that information. Okay, so here's an example from the collections at Museums Victoria. Since we're on the E.J. Dunn, train, we'll keep going on that. So this is a specimen of Corundum variety sapphire. Well, that's how we've registered it, but actually it contains all sorts of minerals: topaz, zircon, cassiterite, garnet. This is a gem gravel, essentially, from El Dorado near Beechworth. And this was purchased from Lillian Dunn, who was Edward Dunn's daughter, in 1948, just after his death. So the next few slides, I'll show you what the data looks like in our EMU database that we use. And then once I've, I guess this is just to show you how I would go about cataloging something, and then we'll move on to the Vic collections and look at how the fields used there might be different and what you might do differently. So because our database contains, I think, over 2 million objects across social history, First Peoples collections, zoology, paleontology, mineralogy. We have these scientific group and discipline and category that just separates out the data. We've got a unique identifier, the specimen's registration number. In the top right, we've actually also got another unique identifier, which is its IRN. So every catalogue record has a sort of, whether it's a fish or a teapot or a rock, has an additional unique identifier that's in the same format. We know it was part of the Edward J. Dunn collection, and we know that we purchased it from Lillian Dunn in 1948. So we've got a previous number here. So previous number was 240. We know that was a number that it had in the E.J. Dunn collection, and we've also described what that number looks like, where it is. Is it on a specimen? Is it on an old label? Seems a little bit dry, but really being consistent in this way will save headaches down the track. We have the collection manager and curator at the time of accession, and we have the last time the specimen was cited, so 1st of August. We have the geological details, so it's a corundum variety sapphire. Corundum is part of the hematite group, which is part of the class called simple oxides. And we have the other minerals that are present. And we've also got these checkboxes for whether we have a photograph. So this particular specimen was figured in the Gemstones in Victoria book that Ollie mentioned earlier. We'll show that in a minute. We have the locality. We don't have any other information about how this was collected, probably by E.J. Dunn, but we don't know that for sure, so we're not going to say that. I will go into, so this is within that particular site, and talk a little bit about giving something a coordinate, sort of spatial coordinates. So the descriptive information that it's from Eldorado near Beechworth is, that's good. But we want to make that data interoperable. We want to be able to, show that on a map somewhere alongside other specimens that, maybe someone else has said a particular gully and hasn't mentioned Eldorado, but has said it's near Beechworth. And so in order to make those two localities interoperable, latitude and longitude are quite a useful way to do that. Although we never want to make that a substitute for the original description, because, that interpretation that I've made estimating that locality could be wrong. But we want to show both if we can. And so that's something I'd encourage you to do. If you've got a locality, I know in Vic collections there are places to put coordinates. The things to think about when you do that is explaining how you arrived at those coordinates. So in my case, I went to Google Maps and saw where Eldorado was and estimated that probably 2 kilometers around that spot, seems like a reasonable, you wouldn't have called it Eldorado if it was any further away. And we also want to record what kind of coordinates they are. So there have been different coordinate systems used over the years. Almost all latitude and longitude that you deal with today will be in the WGS 84, World Geodetic System 84 projection. So that's what we've done there. We record when it was registered, by who. There are 9 vials there. I've given a bit of a description. 9 vials of detrital grains, 1 large vial with unsorted grains, mostly corundum variety sapphire, 8 files containing sorted grains and what each of those are. So as I said before, really you want to make it as clear as possible in words, you know, what the nature of the specimen is, how it's been prepared, anything like that. And finally, there's a reference to this particular specimen in this book, and we've got the figure number and the page number. And so that specimen was pictured in Gemstones in Victoria. So now on to an example from the Burke Museum collection. And I picked this specimen partly because it's got a lot of information on it. It's also interesting because, so you can see on the little that little orange label at the top there, the locality is from Gabo Island, which is sort of just off the coast near Malakuta. And that's one of 2 places in Victoria that has a pink granite, and so it's quite a distinctive specimen. If I'd just seen that, I might have even, I probably would have guessed Cape Woolamai first, because there's more of that material that's at Cape Woolamai on Phillip Island has, you know, made it out. There was a quarry there. But that makes it, I guess, a specimen that I'm relatively confident about that locality information. So, you've got these nice photos of it, which are great, but you also want to be able to, have a machine search for some of that information, the different label styles, things like that. One thing I would note at this point is that you can see that the label with the 15 overlaps the Geological Survey label there, and so that relationship is actually quite an important thing to mention, because obviously then that 15 has been added later. So got the identification, that seems fine. So you've got your unique identifier like we did in the EMU database, you've got the item type, and you've got the item name. So you'll note that the label stuck to it at the bottom says cyanitic granite, or we assume it said that. And so someone has obviously known a little bit about geology when they did this, because that's actually a kind of an oxymoron. Those are 2 different categories of igneous rock, and someone has probably done the research and found out that the Gabo Island stuff is a granite. So this is an example that was done previously. So it's a very good, well put together record, but I'll critique it for the sake of the benefit of everyone here. So the physical description, that's good. It's solid palm-sized mineral. Maybe I call it a rock rather than a mineral. Colored by flecks of pink, red, and grey. So that's quite a good description. I think you'd probably recognize that specimen based on that description. Some other things that you might talk about in that section, I would describe the labels, their colors, the fact that that Geological Survey label looks like it was printed, but then, or stamped maybe, but then the Gabo Island is handwritten in. The different colors of the paper, the fact that these are bits of paper that have been glued onto the specimen directly rather than sitting in a box with it or something like that. I'd also mention things like, what does the surface look like? Is it rough? Often you'll see a rock that's sort of had a slice taken off it. I've got quite a smooth cut surface. Things like perhaps if you've got it in front of you, the grain size, that might be a little bit difficult to go off a photo. And yeah, so those are the kinds of things I'd record there. The inscriptions and markings, that looks pretty good. One thing I noticed is that it's not entirely consistent in that they've noticed that the geo has been torn off logical, but they haven't done the same thing for the end of the word granite, which has also been torn off. And if I was doing that and recording it in that format, I'd also make sure somewhere it set out in full geological survey, syenite granite, because you want those to be searchable. Materials, that looks good. I'd probably also add in the paper, but that covers that. Production methods, natural process. Yeah, that seems reasonable. Obviously, Molly can guide you on some of this terminology, because it will be particular to the Burke Museum collection, and you just want to make sure you're staying consistent. I'm fairly sure that unit of weight is incorrect. It's probably supposed to be grams, so just keep an eye on that. The contextual or historical information, just go back. I would say the part of that physical description that follows the colors of the flecks is really more the kind of information that would go in the contextual description, rather than a physical description of this specimen. You can't tell just by looking at this rock that granite's formed by slow crystallization of magma. So this is a really good contextual information. I learned things reading this. I didn't know about the Gabo Island lighthouse being constructed of the granite from there. So yeah, I think this is, really captures everything that I'd want to. Maybe in the primary significance, I'd also include its scientific significance as an example of a particular material from a particular place. Locality information, as I said, I'd include a latitude and longitude, and probably in the details field there, I'd add information about, what the coordinate system is, how you decided that was what the coordinates were, that sort of information. And the fact that this was donated by Alfred Selwyn is quite interesting. So again, I might go back and add that to its contextual and historical significance, because that is quite an interesting one. And in fact, the date, August 1868, that's the year, or perhaps less than a year, before he was kicked out of the Geological Survey and had to go to Canada and make a life there because of some interesting political machinations in the Victorian government at the time. So thanks for listening. Good luck cataloguing. I'm happy to answer any questions now, or if as you're working through cataloguing, you want to ask any other questions, feel free to email me. And how are we going for time? Maybe we'll leave it there.
Going well, yeah. Thank you so much, Oscar, for that. I think a question time would be fantastic if you're happy to stick around for it.
Yeah, sure.
And first, just thank you so much for going into so much detail. It's really interesting and really specific. And I think it's probably clear to everyone now that there are so many quirks to a scientific collection and a collection like this that just aren't there when it comes to social history or photography that we've already covered. So thank you. Hopefully everyone's absorbed that well, because it is a lot of detail, but I think it would be great to maybe get some questions from anyone, as well as see if we can have a good starting point for our records this week when it comes to what to do when you're not an expert. So my I guess statement just before the questions is, when it comes to that website, the MINDAT website, unfortunately we could not get it working on my computer at the moment, but I would highly recommend deep diving into there as a platform to assist you as you start cataloging. But does anyone have any questions for Oscar at this point? Could be big or small.
I don't have any questions, but I just wanted to say thank you. I think that was really in depth, and it was interesting just to learn about you know, exactly how you would do things, and even just commenting on the texture of the rocket. You know, you may have not have thought of that at the time, but it's good to keep in mind. So yeah, that was, I learned a lot and found it really interesting. Thank you.
Yeah, no problem. I'm glad.
Yeah, and interesting what
enjoyed
you said. I found it quite fascinating when you mentioned the labels that were crossing over and the significance of sort of the layering of labels on one specimen, and how that could actually be used to get that research going, to work out what each of them mean, and understand the history of the item a little bit more.
It's interesting. I mean, at various stages in the history of the collections I look after, there have been attempts to relabel, renumber specimens. In some cases, so we have a separate numbering system for rock specimens and mineral specimens, and in some cases, as you might imagine, those boundaries are a little bit blurry, and things have jumped from one collection to the other and then back again, and been assigned a new number each time. And partly, you sort of you sit there and think, God, why did they do this? But also they didn't have a database. So being able to, go back and say, oh, actually originally, this was the record that referred to it, and we'll just revert to that, wasn't necessarily an option. So yeah,
and I think that's something very relatable for the Burke Museum collection, and I think something with paper-based cataloging that's sort of just part of the process is that sort of seeing there'll be efforts that you can see at different points in time, that a lot of the time are also renumbering of items or recataloguing in a different system. That I always go with the logic or the understanding that there is a logic, and it might just be an insular logic, but there is a reason that someone was doing what they were doing at that time, even if it leads to multiple identifiers or numbers associated with the one item.
Yeah.
But, yeah, I think definitely something to keep an eye on in the Burke Museum collection as well. And to clarify where the descriptions for the inscriptions and labels and things, that will also be in the physical description section, in case there was any question mark over that one.
Yep, sure.
But yeah, anything from anyone else? I feel like that was so much good stuff for cataloging that I know I'll be absorbing it for the rest of the day as well.
Thank you. I just want to say thank you. And I feel like it's definitely one of those things that I don't have any questions now, but I know when I come to look at the items on the screen, I'm going to have a million questions. So,
yeah. Yeah, sure. Well, as I said, happy to help with that when you get to that stage.
So much.
And thank you so much, Oscar. It's fantastic having you on board, and such an expert in the field is very exciting. And yeah, feel free to shoot questions my way or Oscar's way. I'll put Oscar's details into Trello as well, so that you've got a direct source. And Oscar, I hope this is okay. I did ask you earlier, and you did confirm that those slides could also be put into Trello. That
that's fine.
You used for your talk as well.
Yep.
I also asked Oscar if you could have a look at the images for this week's image competition. And I will say at that point, I do apologize, but at that point there were 3 images up that we were able to have a look at. So I thought, Oscar, would you like to announce? I can share the screen so everyone can have a look.
Sure.
At the image.
Yeah.
As long as my computer actually works.
So there was some, apologies to those who hadn't got their images up by the time I looked at them. And I was very tempted by the sugar crystals, naturally, but I ended up going with the starfish. I think that was very cool. And interesting note that while some animals can have 5-way symmetry, no crystals do. So that's one of the things that piqued my interest.
Absolutely beautiful. So I believe that was Billy Joe. So congratulations on this week's success. but the images were absolutely beautiful. I think I was tempted to sort of download a few and start painting, but I don't know if my painting skills are up to up to par for it. But I will also, oh, while I'm there, I should probably, I'm no longer there, but I'll share my screen again for the next week's theme. But I thought, considering the theme of this week, I'd go with rock and roll. I didn't want to put an image up because I thought I might sway you towards either going with a geological image or to do with a music kind of image. So take it whichever way you'd like, but this week it'll be rock and roll for an image. So have a think and upload when you can. But if there's no more questions, then once again, I'd just like to say a huge thank you to Oscar. It was fantastic hearing from you today, and really looking forward to your assistance through the week as well. But yeah, I hope everyone got as much out of that as I did. It was fantastic. And to everyone else, just yell out through the week if you need anything or feel like a chat. I know a couple of people have reached out for different reasons, but just let me know if you need anything through the week, and I'll be uploading everything into Trello as we go. So have a lovely week, and I'll talk to you soon.
Thanks. Bye.
Bye.
Thank you.
Thanks. Bye.
Thank you. Bye.